So lots of skills you've seen before here, possibly a little more difficult than we're used to. Basically, you have to be able to substitute into an equation or formula and solve, or really and calculate or evaluate. So move right along here. This one, 7x plus 5 for x equals 10. So plug in a 10 for x. Right. Multiply 7 times 10, 70. Plus 5, 75. Here, substitute a negative 5 in for x. So 3 times negative 5 squared minus 9 times negative 5. So 3 times, we'll get 25 here. Negative 9 times negative 5 will give me a plus 45. 3 times 25 is 75 plus 45. So we have 120. Next one should be, they should actually give us some values for x and y for this to make sense. So let's just say x is negative 2 and y is 3. So now we can actually do this problem. So negative 2 times x squared, so we'll plug in negative 2 for x, minus 5 times x times y, minus y squared, so 3 squared. So substituting, right, that's a matter of just getting rid of something and replacing it with something equal. So let's see, here we have negative 2 times, we're going to positive 4 out of that. Negative 5 times negative 2 is 10 times 3 is going to be plus 30, and 3 squared is 9. So. Hey guys, I'm not sure how I messed up the video, but I did, and I'm just going to have to explain what I did here. So I left off here, all I did is 30 minus 8 and 9, so I did 30 minus 17 here to wrap this one up, got 13. I mean, basically did the same thing in these next couple. You just got to plug in carefully, right? So negative 5 goes in for x, so plug in a negative 5 for x, negative 5 squared, 4 times negative 5, right? Again, just plugging in negative 5s for x, right? And then negative 5, when you square it, you get a positive 25. 4 times negative 5 is minus 20, and bring down the minus 7. I combined the 20 and the 7 here. They're both negative, so I combined them. Got minus 27. So 25 minus 27 gave me negative 2. Same thing here, just carefully plug in a 5 for x and a 6 for y. So 5 for x, and there's another 5 for x here. This y, that's a 6 here. Minus y squared is minus 6 squared. So when you square the 5, you get 25. Bring down the negative 3. 4 times 5 times 6. So 4 times 5 is 20 times 6 is 120. 6 squared is 36. I still hadn't multiplied here yet. Negative 3 times 25 is negative 75. And then what I did is I added these two negatives and I got a 111. So I did 120 minus 111 and I got 9. So there's that one, or those couple. And same thing down here. I thought I was recording and I wasn't. So let me just explain. So all these definitions here, guys, the terms, right? I know when I have terms because they're separated by plus signs and minus signs. So 12y here is a term. I see a plus sign. 9y is a new term. There's two terms here. If you go to the bottom, you have 4x plus, right, new term 7y, plus 11 is a new term, minus 2x is a new term, minus 9y is a new term, minus 3 is another term. So anywhere I see a plus sign or minus sign, I know I have a new term. So there's that. And then you guys probably remember a lot of this stuff. Like terms have the same variable with the same exponents on the variables. So 5x squared and negative 3x squared, or 7x and 3x, 4y and 9y. Constant term is just a number, right, guys? It could be any number, but if it's just a number, it's a constant. And then we have coefficients, right? Coefficients are definitely a good vocab word to know because it comes up a lot in math. The coefficient is the number in front of a variable term. You can read the numerical part of a term. The 7 here, 7x, 7 is the coefficient, minus 9y, so negative 9 is the coefficient. You can go to a lot of different problems, but let's look. Like here, 4x, 4 is the coefficient. Here's 7y, 7's the coefficient. Up here, 3x squared, 3 is the coefficient. Minus 7x squared, so negative 7 is the coefficient. So anyhow, combining like terms, all you got to do is add or subtract the coefficients if they are like terms. So 12 plus 9, 21, so 21y. 8 minus 10 is negative 2, so negative 2x. 1x plus 7x is 8x. 3x squared minus 7x squared is negative 4x squared. Here I had to identify some like terms. 7x and 3x were like terms, so 7 plus 3 gives me 10x, and then 5 and 8 are like terms, so 5 plus 8, 13. Over here my like terms were again identified by underlining, so you can see single underline, 4x minus 2x are like terms, double underline, 7y minus 9y are like terms, and then triple underline, 11 minus 3 are like terms. So 4x minus 2x gives me 2x, 7y minus 9y gives me minus or negative 2y, and 11 minus 3 gives me 8. So that's, oh shoot, sorry about that. So that's, again, I was just saying 4x minus 2x, right, is 2x, 7y minus 9y is negative 2y, and 11 minus 3 is 8. So, next page, same skill here, combine like terms. These are like terms, they both have x squared, so 5 minus 15 is negative 10. X squared just comes along for the ride. Here I have 9x minus 3x, 6y minus 20y, and 15 minus 16. So 9 minus 3 gives me 6x. 6 minus 20 will leave me with negative 14y, and then 15 minus 16 is negative 1. Alright, just combine like terms. All you do is add or subtract depending on the sign of the term. Here, distribute. Right, 5 times 3 is 15x, 5 times 7 is 35. Bring down minus 6x, 15 minus 6 is 9, 9x, bring down minus 35, that one's done. Here, when you distribute, you got to distribute basically a negative 1, right? That negative sign is like a negative 1, so we'll have a minus 3x, negative 1 times negative 4 is a plus 4y, negative 1 times 6 is minus 6. Combine like terms. 2x minus 3x is negative 1x or negative x. Plus 4y has no like terms there. Minus 6 also just comes along for the ride. Here I have to distribute a negative 1 again. So, right, distributing a negative sign is like distributing a negative 1. So we'll have a minus 15x, a minus 2y, and a plus 1. My like terms here are 7x and minus 15x, or a negative 8x. Negative 2y and plus 1 have no like terms, they just come along for the ride. Next I have, again, more of the same, distributing and combining like terms. In fact, wait a second here. These are the same problems, so we definitely don't want to do these twice, so just use those 3 as practice. Sorry about that. That needs to be fixed. And down here, let's see. An equation, right, gives me a definition for an equation. Don't really need that, but let's see this formula. P equals 0.72x squared plus 9.4x plus 783. It models the gray wolf population in the United States X years after 1960. Use the formula to find the actual population in 1990. Does the formula model the actual data shown in the bar graph on page 276? Okay, well, we'll have to look at that, but for now, we can use this formula, and then X years after 1960, guys, so 1990, right, it's 30 years after 1960, so again, X equals, if you just subtract, right, how many years since 1960 when it's 1990, it is 30 years, so X is 30 for this one, so I can, according to this, I can model the gray wolf population in the United States by using that formula. 0.72 times 30 squared plus 9.4 times 30 plus 783. So moving along here, I got 30 squared is 900, 9.4 times 30 is 282, and here 0.72 times 900 is 648, so plus 282 plus 783 1,253. That'll give us our total. Definitely going to want to use a calculator on this problem, guys. So let me add up that final total. 1,713 gray wolves in 1990 is technically what this is saying. So if you missed any of that up there, again, it was an equation that models the gray wolf population in the United States X years after 1990. So however many years after 1990 it is, you fill that in for X. This last one, it's asking about the gray wolf population again, so it is going to be the same formula. This formula again. So I already figured out here that in the gray wolf population in 2000 would be 40 years after 1960, so X is 40. Let me go ahead and plug that into, again, to that same equation, the gray wolf modeling population. So 40 squared plus 9.4 times 40 plus 783. So again, I'm just plugging in and calculating here, guys. 40 squared is 1600. Whoops. 0.72 times 1600. 9.4 times 40 is, again, use a calculator. It's 376 plus 783. Here, multiply 0.72 times 1600. That is 1152. Again, I'm using a calculator for all this stuff, so make sure you use one. It's a little too much labor to do all this by hand. So last step, if you add all these numbers up, right, you get the gray wolf population in 2000. So adding these up, you got 2,311 gray wolves. That would be in the year 2000. That's according to the formula, guys. So these two problems, the formula allows us to calculate or estimate, by calculating what the gray wolf population will be. But if you look at the actual data, in this table here, you can see that our numbers aren't too bad. In 1990, I think our number was 1,713 wolves, and it says there was 1,700, so the formula actually models the data pretty well. Here in 2000, there's 2,300 wolves, and we calculated 2,311, so the data here is actually modeled pretty well by the formula. So that's about it. Again, it asks that, how well does the formula model the data? Well, I think it models it pretty well. It was only off by 13 here and 11 here, so not bad.